Hello, today we're going to talk about Newton's law of motion. And before we get into our lesson, we're going to listen to this YouTube video that goes into detail on Newton's laws of motion.
There are a lot of things happening in the world. Objects move, fall, and rest all around us. You may think you understand why things move or don't move, but did you know that the forces acting on these objects can be measured and their motion predicted? Renowned English scientist Sir Isaac Newton wanted to understand the world better. He thought he could describe the movements of the universe through mathematical observation. In 1687, he published these observations in a book, which outlined his understanding of the laws of motion. These 3 laws of motion are still in use today and can help us understand the relationship between a body and the forces acting on it. Newton's first law of motion is often stated as, an object in motion will stay in motion, and an object at rest will stay at rest, unless acted upon by an outside force. This law is also called the law of inertia, since inertia is the tendency of an object to keep doing what it's doing. You have experienced Newton's first law if you have ever used a swing on a playground. In order to start swinging, you have to use a lot of force, but once you get going, it can be hard to stop. Here on Earth, there are some forces working on objects all the time. When you throw a ball upward, it doesn't keep going up forever because the force of gravity pulls it downward. Once it hits the ground, friction, or resistance caused by surfaces rubbing together, will eventually bring it to a stop. Newton's second law says that force is the product of mass times acceleration. Mass is the amount of matter, or stuff, in an object. To make something accelerate or speed up, you have to apply a force. The amount of force it takes to move an object changes depending on how massive it is. Think about it. You would need more force to move a bowling ball than to move a beach ball of the same size. The greater the mass of the object, the more force it will take to accelerate the object, and applying more force will make the object move faster. Newton's third law of motion says that for every action, there is an equal and opposite reaction. If you exert a force on an object, it exerts an equal force back on you. For example, a ball hitting the ground exerts force downward. The floor exerts an equal force upward. This is the principle that allows rockets to launch or jellyfish to swim. By exerting a force downward, an equal and opposite force pushes upward, and the object accelerates. We can also see the third law in action when birds fly. Their wings press down against the air. The air pushes up against their wings, allowing them to move upwards. Another good example of this law is skateboarding. The skater pushes backwards against the ground with their foot. The ground pushes forward with equal force. Since the wheels of the skateboard reduce the friction between the person and the ground, they are able to move forward for some time before forces slow them down again. Although these 3 laws were written down more than 300 years ago, they are still important now for understanding the way things move and represent the foundation of classical mechanics. I hope you enjoyed learning about Newton's 3 laws of motion today. Goodbye till next time.
Okay, so that is Newton's three laws of motion. And we're going to get into our assignment here. It says, reflect on the essential questions before you dive in. What are Newton's laws of motion? And how do Newton's laws of motion apply to sports activities, amusement park rides, and Earth's tectonic forces and rocket launches? If you can answer one of these, move and put a check or an X by 1 or 2 here. Force is a push or a pull on an object. It causes a change in motion of an object. An object's mass multiplied by acceleration. So force equals mass times acceleration. This is measured in newtons. What unit is force measured in? Put your answer here. Balanced force, two forces acting in opposite directions of an object and equal in size. Object stays still or continues moving at the same speed and in the same direction. What is the forces? Why are these forces balanced? Put your answer here. Unbalanced forces. It causes a change in motion of an object and it causes acceleration, such as a swing. Net force is the combination of all forces on an object, and it's measured in newtons. How could you make the forces on the right balanced? Put your answer here. Friction. The force that causes a moving object to slow down when it touches another object. One object rubbing against another object. Since friction is a force, what unit is friction measured in? Put your answer here. Speed. Speed is the way of measuring how quickly something is moving or being done. For example, a motorcycle is going 55 miles per hour, 55 mph. Another example is sweeping the floor for 5 minutes. Velocity, the rate at which an object changes in position or moves in a direction in a specific direction. For example, 35 miles per hour west. How are speed and velocity different? Put your answer here. Acceleration, the rate at which an object changes its speed or direction, speeding up, slowing down, or changing direction. For example, downhill on a roller coaster, uphill on a roller coaster, or turning a corner even if your speed stays the same. Applied force, a force that is applied to an object by a person or another object. An example is a person pushing a box up a ramp. Miley Matias. Another example is a bulldozer moving dirt. What are the 3 times acceleration happens? Type your answer here. On this, you will take and you will read the definition and choose the term that best matches. When you click and move it over that particular definition, then you will see if you are correct or not correct. For instance, a push or a pull. A push or a pull, for example, force. Force can be moved over, and that is correct. You must have the word correct for each one of these. Sir Isaac Newton was an English physicist, mathematician in the 1600s. He was one of the most influential scientists of all time. He formulated 3 basic laws of motion, referred to as Newton's laws of motion. His first law, or the law of Inertia is when an object is at rest, it tends to stay at rest unless acted on by an unbalanced force. For example, sitting on a couch. Inertia is a tendency to do nothing or remain unchanged. An object in motion tends to stay in motion with the same speed and direction until acted on by an unbalanced force. For example, a satellite orbiting Earth. List one example of Newton's first law. Let's summarize what we know about Newton's first law of motion. Click and drag to the correct definition for inertia and friction to their correct location. Then you're going to type 3 examples that demonstrate the Newton's first law. Newton's second law are law of force and acceleration. The acceleration of an object is dependent on 2 variables. A, net force. B, the mass of the object. You can use this triangle formula to help you solve for force, mass, and acceleration. So, to get force, you say mass times acceleration. To get your mass, you say force divided by acceleration. And to get your acceleration, you can say force divided by mass. Acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. What does the A represent in the triangle? Let's practice. What does F equals m times A mean? What would be the formula if you wanted to solve for the acceleration? Use the formula to make your calculations. Solve these 3. A soccer ball was kicked. It had the mass of 0.42 kilograms and accelerated at 25 mass times s squared. What is the force? A force of 20 newtons act upon a 5 kilogram block. Calculate the acceleration of the object. An object with a mass of 300 kilograms is observed to accelerate at the rate of 4 mass divided by s2. Calculate the total force required. Newton's third law are the law of action and reaction. For every action, there is an equal and opposite reaction. For example, a rocket taking off. How does Newton's law relate to the Earth's plate movements? Unbalanced forces create earthquakes, volcanoes, rift valleys, and other geological features when plates are under tension. Right here, you will complete all of these sections together and type in your answers. So, who was Sir Isaac Newton? What is Newton's first law? What is Newton's second law? And what is Newton's third law? Determine which one of these would be Newton's first law, Newton's second law, or Newton's third law, and drag the number to the appropriate box. A satellite orbiting Earth. Your shoulder is pushed backwards after shooting a shotgun. F equals m times A. A soccer ball accelerates faster than a bowling ball when the same amount of force is applied.
Attention student, Jatisha Shorter.
A magician pulls a tablecloth out from underneath dishes and the glasses don't fall. When you paddle a canoe, your oar goes backwards, but you go forward. A picture hanging on the wall does not move. Earth orbiting the sun. A rocket blasting into space. A speed skater that goes faster around the track.
Attention.
A speed skater goes faster around the track as they push harder with their legs. A rocket blasting off into space. The Earth orbiting the sun. A picture hanging on the wall does not move. Explain how Newton's laws apply to sports activities, amusement park rides, Earth's tectonic plate activities, and the rocket launches. You will mark down how each law applies here. And that is all for today.